Yes, someone is unmuted. Mute yourself. Okay, yeah. Now we will start the lesson. Yesterday we discussed about the introduction of LED, as well as what we discussed. So we discussed about the direct band gap semiconductors and indirect band gap semiconductors. Okay, I think everyone understood about the direct band gap and indirect band gap. Okay, if you will take direct band gap semiconductor, only direct band gap semiconductors are involving in the what is that this that means emission process. So it will emit the band gap semiconductors only emits the photon radiation. Okay, so radiative recombination occurs only in case of uh, direct band gap semiconductors. In case of indirect band gap semiconductor, so only phonons will be emitted. Phonons, that means phonons are involved in a indirect band gap semiconductors. Okay, so in case of direct band gap semiconductors, photons will be involved. Photons will be involved. Okay, that is about the direct band gap and indirect band gap semiconductors. Now we will discuss about the light emitting diode, LED. Okay, first of all we will going to the introduction of LED. LED is LED acronym is light emitting diode. Okay, the light emitting diode is solid state light source. It is an optoelectronic device in which a forward biased PN junction emits light. It converts electrical energy into light energy. Okay, so this is a solid state device, and uh, so which is connected in forward biased PN junction diode. So that means, so that LED is nothing but it is a forward biased PN junction diode. It will be used in case of for constructing the LED. We'll use the PN junction diode that also connected in forward biased. Okay, and what is the here LED means it converts electrical energy into light energy. Okay, now yeah, how PN junction here we will discuss. So before going to that, that means that what is the principle of LED we will discuss here. So that is the principle of LED is injection electroluminescence. Principle of LED is injection electroluminescence. So what is the definition of injection electroluminescence? Means when a PN junction is forward biased, minority carriers flow in large number into regions where they can recombine with the majority charge carriers, so producing light in the visible or infrared region. Okay, that is about the uh, the principle of LED. That is about principle of LED. What is that? It is the principle injection electroluminescence. Okay, now we are going to the theory. Okay, in case of PN junction diode, it has a large concentration of electrons in conduction band as well as so conduction band in of N region, and similarly large concentration of holes in the valency band of P region. Okay, if you will take PN junction diode, so here if you will P and N regions both are so heavily concentration of electrons as well as holes in N region. So concentration of electrons is high. P region concentration of holes will be high. Okay, so where electrons will be present? So in conduction band electrons will be present. Where holes will be present? So in valency band holes will be present. Okay, and under forward bias condition the electrons move forward into the deposition region and occupy energy levels in the conduction band. Okay, So here, so this is PN junction is in connected in forward bias. Forward bias. So in forward bias, what happened here? So for yeah, so that means the charge carriers come together. In case of forward bias, the charge carriers are come together. So that means electron will move towards to the depulsion region. So electrons are repelled by the negative terminal of the battery. So that's why those will move towards to the depulsion region. Similarly, holes. So holes in P region. That means P region is connected to the positive terminal of the battery. That's why holes will move towards to the depulsion region and occupy the energy levels of the valency band. Okay, already we know that. So holes will occupy the energy level of the valence band. So similarly, electrons will occupy the energy level of the conduction band. Okay, the electrons in conduction band are directly above the holes at the edge of the valency band. Okay, yeah, see here, when an electron from the conduction band jumps into the hole in the valency band, recombination occur and excess energy is emitted in the form of photon. Okay, see here, so before applying any external field, so this is the P region of the PN junction diode. This is the N region of the PN junction diode. Okay, so in case of P region, what are the majority charge carriers? Holes are the majority charge carriers. Holes are the majority charge carriers. Those holes will occupy the valency band. Similarly, in N region, electrons are the majority charge carriers. Those electrons occupy the conduction band. Conduction band in N region. Okay. Now coming to the, now we are connected to the forward bias. So this PN junction diode is, we are connecting in forward bias. Okay, so positive terminal of the battery is connected to P region and negative terminal of the battery is connected to the N region. In this case, what happened means, so these electrons are repelled by these negative terminals. That's why, so electrons will move towards the, so these depulsion region. So this is the depulsion region here. Okay, so if you connect the forward bias means electrons will move towards to the depulsion region. Okay, similarly, holes will move towards to the, so depulsion region. Okay, holes are repelled by the this positive terminal. That's why holes will move towards to the this region. Okay, already we know that holes will be present in conduction band. Similarly, electron will present in valency band. Okay, at the junction, at the edges of the P and N region, at the edges of the P and N region, that is called a junction. Okay, at the junction, what happened here? So recombination will be takes place. Okay, so because of that recombination, what happened? Photon will be emitted. Because of that recombination, photon will be emitted. Okay, here photon will be emitted in different directions. Okay, so this is okay, this is about the, so theory. Okay, now coming to the, so here different colors will be emitted. Different colors of the semiconductor will be present. What is the reason for different colors? Okay, yeah, a semiconductor material used for manufacturing LEDs are compound semiconductors. Already we discussed. So here for preparing the, so LED, so we'll use the compound semiconducting materials. So that compound semiconducting materials means, so third group elements are combined with the fifth group elements. So by using third group and fifth group elements, so we can prepare the compound semiconducting materials. So examples of compound semiconducting material here. So gallium arsenide and gallium arsenide phosphate and gallium phosphate. These are the some examples. So gallium, so indium phosphate also there. Gallium. So many examples are there. So these are the some examples here. Okay. Now the color or wavelength of light is emitted by LED depends on the percentage of doping of phosphide in gallium arsenide phosphide and gallium phosphide. Okay, so here actually this color or wavelength is nothing but color, because different colors have different wavelengths. So that means color is depends on the, so what is the wavelength? Okay, so this wavelength is depends on the, so band gap band gap between the valency band and conduction band, valency band and conduction band. Okay, so that's why, so for if you change the concentration of doping concentration, that band gap also changes, band gap of the material also changes, depends on the doping concentration here. So that emitted light wavelength will be changes, depends on the doping concentration here, emitted wavelength will be changes. That's why color of the light will be, color of the emitted light, LED light will be changes. Okay, suppose if you will take gallium, if you will take gallium, so the if that gallium is doped with suppose arsenide and phosphate in this case, and here gallium is doped with only phosphate. Okay, so in these cases, if you change the ratio of phosphate, okay, phosphide, okay, so what happened if you change the ratio of phosphide, so that color will be changes, colors will be changes, we will observe that. Yeah. uh, so if you change, what happened means here, so one more thing also will be done here. So if you change the, so doping concentration, what happened, refractive index of the material also changes. Okay, refractive index of the material also changes. If you will take gallium arsenide phosphate, so for this refractive index is 3.3. So if you will take gallium phosphate, so for this refractive index is 3.8, 3.8. Okay, so this refractive index, so critical angle of the, critical angle also depends on the refractive index. Critical angle is nothing but, so that light will come out from the semiconducting material in that, so that particular light will be, yes, so in that, so light will be emitted in the particular angle. So that angle, that means for different materials critical angle will be different, so that angle should be greater than the critical angle, then only that light will be come out, light will be come out. Okay, so that critical angles is different for different materials. So we'll discuss deeply this critical angle uh, in case of fiber optics. In fiber optics chapter, we'll discuss totally that about this critical angle. Okay, so based on this critical angle, whether light is come out or not. Okay, so for different materials, it will be different critical angles will be there. So suppose if you will take, so gallium phosphate means that refractive index will be 3.3 and its critical angle is 15 degrees. And if you will take gallium phosphate, so that refractive index is 3.8 and critical angle is 18 degrees, because there is a relation between refractive index and critical angle. So theta c is equal to 1 by mu, 1 by mu. Okay, if angle of the so that, yeah, so previously we discussed here, so light is emitting, so when light is emitting out, so if that angle of the light, so angle making, so suppose this is moving like this direction, it's making an angle with some axis here, vertical axis if you will take, so that angle will be so greater than critical angle, then only light will come out. Okay, like that here. So in total internal reflection will be takes place, otherwise if you will light angle is less than critical angle, total internal reflection will be takes place. So at that situation light will not come out. Okay, we'll discuss this critical angle in so next chapter deeply. Okay, now coming to the here, if you will take gallium phosphide, gallium phosphide, so which color it will emit means red color. So that means depends on the phosphide concentration. If phosphide concentration is low means its color will be red. Suppose if phosphide concentration is more, so that phosphide ratio is high, phosphide ratio high means so green color will be emitted, green color will be emitted. That means here, so depends on the ratio of the gallium and phosphide. If ratio will be, so phosphide concentration will be less means so red color will be emitted, phosphide concentration will be high means so green will be emitted, green will be emitted. Now if you will take another example, gallium arsenide phosphide, gallium arsenide phosphide, here also same, its color light color will be depends on the phosphide concentration. Suppose here, so phosphide concentration will be low means yellow, so if you, it will be, yeah, so high means it will be red. Okay, depends on that concentration, its color will be different. Okay, now gallium nitride, gallium nitride, so in this blue color will be emitted. Blue color will be emitted. If you will take gallium arsenide, so IR, invisible wave, IR radiation. This is invisible. Okay. So in your remotes, in remotes already we will observe the LED. LED will be there. So that emits the IR radiation. So did you observe the remote? In that remote, there will be light, like small bulb size. It will be there on edges. So that is the LED. So in that LED, so IR radiation will be emitted. IR radiation will be emitted. Okay. So that's why. So depends on that wavelength also. We can use it as a that LED. LEDs in remote. Okay. So now coming to the uh, construction of LED. So here, so colors will be depends on the which type of material, as well as so the ratios also, materials ratios. Okay, so depends on different types of material will emit the different colors, because so those type of material, so depends on the type of material, so energy band gap will be depends on, energy band gap of the materials will be depends on. So that's why if you change that material means, so automatically color will be changes, okay. Yeah, now coming to the construction of LED. Now here a N-type layer is grown on a metal substrate and P-type layer is grown on it by process of diffusion. Okay, so the P layer is made very thin, prevent to loss of photons due to absorption in this layer. Yeah, see here. So this is initially we are taking one metal substrate. Okay, so in that metal substrate we are doping N layer. So that means suppose if you are taking gallium arsenide we are taking the gallium arsenide material. In that gallium arsenide, if you dope with the pentavalent element, so what happen? It will become semiconductor. That gallium arsenide N-type semiconductor is doped on a, if you will take any metal substrate, so on that substrate, so one layer will be deposited, one layer of the what is that N-type semiconductor is deposited. Semiconductor is deposited. So there are so many deposition methods will be there: physical vapor deposition, chemical vapor deposition. So like that, so many deposition methods will be there. Okay. So by using those methods, so we can first of all, so we'll take the metal substrate. On that metal substrate, so we will deposit the N-type semiconductor. Okay, so that N-type semiconductor grown on a that substrate. Okay, now so on that N-type semiconductor, on the above the N-type semiconductor, so again we will deposit the P-type. So P-type semiconductor, that P-type layer will be grown on the N-type semiconductor. If you doping here, this is the N-type and this is the P-type. Here junction will be formed. Here in between, so P and N region junction will be formed. So this is the PN junction. Okay. So this is very small size. If you will take, so we can prepare in micrometer size also. We can prepare so these diodes in micrometer size also. These LEDs, and so that means in that LED we are using here so PN junction diode. So how we can make the PN junction diode means, initially we can take this one metal substrate. On that substrate, so we can deposit the N layer. So that means N-type semiconductor layer initially. So on the, it will be grown on the substrate. N-type semiconductor layer will be grown on the substrate. On the N-type semiconductor layer, above the N-type semiconductor layer, so P-type semiconductor will be deposited. So that P-type semiconductor will be grown on the N-type semiconductor. Here, so there are two different regions. This is N-type and this is P-type. So that's why here, so what happened? So junction will be formed in between the N and P-type. Okay, one more thing we have to observe here. So this thickness of the P will be very small. Thickness of the P layer. So p-type layer, p-type semiconductor layer will be very small, because at the junction only light will be emitted. At the junction only light will be emitted. Okay, so if light is coming out means, so that means if the thickness of the layer p layer will be high means, so that it's what happen, some light may absorb by the p region. Okay, that's why if it will be thickness will be less means, so it will easily come out from the, so from the this junction, from this junction. Okay, this is about the, so how we will deposit the p layer and as well as n layer. Okay, now coming to the, and we are taking here one more thing, so this p layer thickness will be very small. Okay, we will go to the next point. uh, Metal connections are made at the edge of the p layer in order to allow more central surface for the light to escape. Okay, see here. So if you observe here, so this is the p layer. So here one metal connection is given, and one more thing here. So one more metal connection is given. One more metal connection is given. Okay, so this is why we are giving means here. So for giving the yeah, we have to connect in forward bias and reverse bias. So for that we have to connect the, so battery terminals for that. So that's why we need some metal substrate here. We need some metal substrate to provide the, so charge here, to provide the voltage, to supply the voltage. So we have to connect one metal substrate. Okay, so metal substrate is connected in two edges. So there will be in middle there is a gap. Then middle there is a gap. Why that gap means? So for emptying the light out. For emptying the light out. So in center there will be a gap. In edges. So there is a ohmic contacts. Ohmic contacts means any metal surfaces. Any metal surfaces are connected. Any metal surfaces are connected above the P region. Okay. And next, a metal film is deposited at the bottom of the substrate uh, for reflecting as much light as possible towards to the surface of device, and also provide electrode connection. Yeah, similarly in case of n region also. Okay, n region also what we are doing here. So one here also one ohmic contact, one metal film is deposited. So what is the use of that metal film means? So if any light is coming in downward direction, that is that light is reflected by the this metal surface. That light is reflected by the metal surface and goes to the above direction only, Okay, so that's why we are, what we are taking here. So metal surface, this also used for ohmic contact. So ohmic contact means for n region what we have to connect in here. So n region, negative terminal of the battery is connected. Similarly for positive terminal of the battery is connecting. Okay, for getting the forward bias. So so we are connecting here some metal surfaces. We are depositing on that PN junction. So we are connecting some metal surfaces. For P region, we will connect the metal surfaces like on edges. So for N region, total bottom. So all bottom will be, so we will deposit the one metal film. Okay, so that will be act as a, so ohmic contact, as well as it will reflect the light whatever coming downwards direction. Okay, so this is about the what is the construction of LED. And one more thing will be there here. Yeah, so this is the total LED structure. So only we discussed previously inside this chip. So inside that PN junction, only this one. Okay, so now we are discussing here outer layers also. So the LED consists of chip of the semiconductor. Okay, see here. So this is the chip of the semiconductor. So whatever we discussed, so this is the only one chip. So approximately we can prepare. So in micrometer size chip also we can prepare. Okay, yeah. So that the chip will be so placed on the center here. The chip will be placed here. Yes, who is that? Okay. Now LED is consist of a chip of a semiconductor material doped with impurities to create a PN junction. Okay. So that means the chip is prepared. So by using PN junction, already we discussed that the chip is placed here. Yeah, the chips are mounted in the reflecting tray in order to increase the light output. See here. So in the center chip will be there. So below that chip, yellow colors will be there. Na? That yellow color will be the reflecting tray. Reflecting tray. Okay. If light is emitting, suppose see here that LED emits the light here. Suppose that LED emitting light, so going to the downward direction sometimes. So at that case, what that tray does means, so it reflect the, so whatever light is going in downward direction. Okay, if any light is going to the downward direction, that tray reflects. That tray reflects the light. Okay, so that is the use of the tray here. That tray is reflecting tray. So in that tray, chip will be placed. Chip will be placed. So if any light is coming downward direction, that tray reflects that light. That tray reflects that light. Okay. Now coming to the contacts are made on the cathode side by means of conductive adhesive, and on the anode side via gold wire to the lead frame. See here. Okay, this is the lead frame here. So this is the lead frame. So in that lead frame, so cathode is connected. This cathode is prepared by using adhesive, conductive adhesive. Okay, and this anode, that anode is will be a small gold wire. Okay, very thin gold wire. Okay, so this is the yeah. So this is the lead frame. This is the lead frame. So this total chip will be so fixed on the this lead frame. This lead frame. So anode is connected to the one side of the lead frame is anode is connected. Another side is so cathode is connected. That cathode material is prepared by using so conductive adhesive material, and anode is prepared by using so gold small gold wire. Okay. Now, so the plastic case enclose the chip area of the lead frame. Okay, this total lead frame will be there. Na? That lead frame will be so by using some plastic, we can we can enclose the this lead frame. We can enclose this lead frame. Okay. Yeah, this is about the construction of LED. This is the construction of LED. See here, this is the construction of what is that PN junction diode. PN junction diode. Okay, so this is the total construction of LED here. LED. Now coming to the working principle of LED. How it will be works, we will discuss now. Is connected to the N-type layer, and positive end of the battery is connected to the P-type layer of LED. Then electrons and holes start moving. Okay, see the diagram here. So we are taking one battery here. So that battery positive terminal is connected to the P region of in this PN junction diode. That means in LED, so we are using PN junction diode. That's why so LED one terminal is connected to the positive region, and this N region is connected to the so negative terminal. Okay, N region majority charge carriers are electrons. That electrons will move towards to the so deposition region, as well as holes will move towards to the deposition region. Okay, what is the reason? We know that. Okay, next, if we try to run current, yes. So here, so this is given regarding about the forward bias. So above first one is the forward bias. Second one is the second point is given the reverse bias. Suppose if you are connecting here, so negative terminal of the battery is connected to the P region. Okay, similarly positive terminal of the battery is connected to the N region. So that means if you just exchange the terminals, what happened? So these current is does not passing. Because electrons will move like this direction. So holes will move like this direction. Okay, in case of reverse bias. That's why there is no current flow. There is no current flow. So in that diode, okay, no current flows across the junction because holes and electrons are moving away from the junction. Okay, now coming to the, so if you connect in forward bias, what happened? The holes existed. Yeah, so one more thing point we have to discuss here. So here, if you will take these all holes will be present on, so the holes will having lower energy, electrons will have higher energy, electrons will have. Okay, so if you will take holes means that energy level will be less than the energy level of electron. Okay, see here, the holes exist at the lower energy level. Okay, than free electrons. So free electron energy level will be higher. Already energy level diagram we discussed. Okay, in that energy level diagram we place the electrons. That means the electrons will be in conduction band. We place the electrons above and holes will be below because holes have less energy. Okay, therefore when free electrons falls into falls it, that means these free electrons recombine with the holes, what happened here? So electrons have high energy, holes have less energy. So in that recombination process, electrons losing some energy. So because, so electrons coming to the lower energy state, and recombine with the hole. So that's why electron is losing some energy. So that whatever the energy is lost by the electron, that will be emitted as a light. Understood? So here electrons have high energy, holes have low energy. So if electron, whenever combine the electron and hole, what happen? Electron energy is reduced. Okay, that's why electron loses some energy and recombine with the hole. In this process, electron is losing some energy. That lost energy is emitted in the form of light. Okay, so this is the, yeah, so this is the how light is emitting here. That is the working of LED. Now characteristics of LED. So characteristics. There is no reverse bias. If you will connect in reverse bias means, so LED doesn't work. LED does not work. Okay, so that's why only here, so we'll discuss about the forward bias characteristics. Here we are taking the LED in forward bias. So okay, we are connecting the positive terminal to the P region and negative terminal to the N region. Okay, simply how we will represent the LED means, so like a diode only, So here light is emitting. That's why we'll make some symbols. We'll make some light emitting symbols. This is the representation of the LED here. So LED positive terminal is connected to the LED P region is connected to the positive terminal of the battery, and negative terminal of the battery is connected to the LED N region. Okay, and we have to use some resistor here. Okay, so resistor. So why we are using resistor means, so so there is a what happen if already we know that the diode characteristics. So if voltage is greater than the, so threshold voltage, applied voltage is greater than threshold voltage, so current will be increases very drastically. At that situation, may chance to short circuit. Okay, so that's why, so we are using some LED. So for reducing the, so that overflow of current, we'll use some resistor here. Okay, some resistor here. So that resistor is connected in series. Okay, so now this is the forward bias of the LED. Okay, in forward bias, what happened? Okay, this is the, so IV characteristic curve of LED. If you observe it, so up to particular voltage, so if you observe that there is no current flow, that means that this LED does not glow. So up to particular voltage. Okay, so if voltage is greater than, so particular voltage, so current flowing through the circuit, then LED will be glows. Okay, so because there is a deposition region in between the so P region and N region. Okay, so P region and N region. Suppose if electron is jumped from so valency band to suppose so to overcome the that deposition region, so it should have recombined with the pole in the valency band, N region valency band. So that's why what happened, you should have to overcome the deposition region. So that's why it needs some energy, it needs some voltage to overcome that deposition region. So that's why, so up to particular voltage there is no flow of current, so that LED also does not glow. Okay, so after that so here uh, after that particular voltage only it will glows. So here scale is taken wrong, so here every time 0.5 is taken, that is wrong. That scale is wrong here. So 0 0.5 1 1.5 like that. Okay, so here this is the current in milliamperes. Okay, so at a particular voltage only, so that it starts to glow. That is the IV characteristics of the LED. Now coming to the some applications of LED. Be used as a inductors and signals. Okay, so we'll discuss deeply that what is the inductors and how it will be used in signals. Okay, and lightning. Lightning also we'll discuss, and data communication and other signaling. So we'll use. Okay, so inductors and signals that will be there now. So we'll discuss that. So lightning also we'll discuss in next class, and so data communication and other signaling, this will be also we'll discuss in next class. Okay, so these are the applications. So applications of LED. Okay. Yeah. Any doubts on this? Do you have any doubts on this topic? Okay. So everyone have to submit the assignment on or before Monday. Okay. I extended so 1 day extra because of your request. Okay. So actually today you have to submit. You said that some exams will be there. So that's why. So you have to must submit the assignment. So on Monday. So Monday, so before 10 o'clock. Okay, so first of all, I will take the attendance. Anyone have any doubts, you can ask, otherwise you can leave from the session.
Sir, on fifth question, I have one doubt, sir.
Yes, tell me.
The question at the
So your voice
you have
is
said
not
that write few application.
applications, LED applications.
Yes,
You are
in
asked.
fifth question,
You are
write
asked
applications. What?
assignment questions. You are asking.
Once I will read the question. Yes, sir.
So fifth question. What is that fifth question?
Explain the PN junction diode without bias forward and
Yes.
forward and reverse bias conditions with the need diagram. Explain the IV characters. That's okay. Can you write few applications అన్నది కదా?
So applications అంటే
దేనికి
మనం
applications IV characters.
that is the main question is the Gina diode. Okay, so that is the Gina diode applications. So IV characteristics means that
Sir, మీ voice break అవుతుంది.
Yeah, so Gina diode will be there na. Applications of Gina. Applications of Gina diode, that is the mainstream, that is okay. So we have to write the applications
Your
of
voice
the
is
Gina.
breaking, sir.
Voice is breaking. 1 minute. Yeah, so applications
Yes,
of Gina. Now it is okay. Voice. L6. Am I audible?
Not hearing, sir.
L6. Am I audible or not? Am I audible?
Yes.
1 minute. Yeah, 1 minute. Okay. Am I audible?
Now it's clear.
Yeah. So here, so your main question is Zener diode. Okay. So Zener diode applications you have to write. So there is no separate applications for forward bias and reverse bias. Okay. So Zener diode is main. That applications only you have to write. So Zener diode, already we know that simple application. Zener diode will be act as a voltage regulator as well as a meter protecting device. Already I told na. Those are the applications.
So 1 minute. What is fifth question? So not sixth question.
Fifth question PN junction diode na.
Application.
Fifth question, yeah. So what is the mainstream will be there? That only you have to write. What is the main question will be there? That's only we have to write. So PN junction diode means, so for that PN junction diode only you have to write.
Junction diode.
Yeah.